Hey guys, how are you? I hope you all are doing well. Well, currently I'm located in Korea, so it's not my regular setup. It's my regular setup is anyway not that fancy, but whatever. So today, without wasting more time, we're gonna talk about how not to use on conditions when you are trying to filter while doing a join in PostgreSQL. Okay, or I should say like SQL. So, if you're new to this channel or the newsletter, I really appreciate you taking a look. If you like the value of what I have to say, what I create content on, uh, hit a like button, subscribe to the newsletter, and you can get access to the premium content on by subscribing to the newsletter premium for premium version. So anyway, this video topic is more about, I would say, like beginner intermediate level, more than advanced. So without further ado, without further ado, whatever, without further ado, let's take a look into the problem at hand and what is the issue, where can it cause confusions, and what to look out for. Okay, so let me change my screen. Okay, there we go. All right, so we are talking about filtering with join on conditions. Okay, or how not to join in PostgreSQL, right? So for this particular example, I'm gonna be creating two tables. I already did this, of course. I tried it out, and I created some dummy data, some dummy tables, so that we can try it out. I can show you what is the issue, what can happen, and what to watch for. Okay, so here I'm gonna recreate the tables again. So before I recreate, I'm going to drop the tables. 1 second. Okay, cool, awesome. All right, so there are two tables, departments and professors. Okay, a professor has a department ID, which is a reference. It's a integer data type, but it refers the department table on the department's ID column. The ID is a serial data type, and similar is the ID here. And there's a name in department, there's a name of the professor, and there's a department ID. All right, pretty simple. So here I am creating the table. Create table if not exist departments. ID is serial, so it's gonna auto increment. While the name is a varchar, so we can provide whatever name we want. Okay, I could do first name, last name, but that's not super important here. So let me run this. Okay, and then create table if not exist professors, where ID is a serial, primary key, name is the name of the professor. Actually, in the department we can have just name. In the professor we can have full first name, last name, and so on. But I'm just gonna stick with name. Then we have department ID, which is reference, or it is a reference to the ID column of departments. Okay, so let's create this one, and we created this guy as well. All right, now I'm gonna add some dummy data. So this is pretty simple. Insert into departments, and ID is a serial, so I don't have to add ID in, like I don't have to insert. So all I have to provide is name. Okay, so name is physics department, maths department, chemistry, and geography department. Okay, and 4 rows have been created. Awesome, let's move on. Insert into professors, and professor also has an ID serial column, so I don't have to add this. I mean, I don't have to provide insert because Postgres takes care of this for me. It uses sequence data structure, or I should say sequence data type in the background along with integer. So insert into and I have a video on that if you are interested in learning about sequence and how it works, or serial and sequences, then take a look into the video on the channel. So here we have insert into professor. The name is all these name, and the department ID is the department ID which is coming from departments table. So actually before we move further, let's actually take a look into each table. Okay, so department table is pretty filled up. It is physics, maths, chemistry, geography, and PostgreSQL allotted an ID to it. Pretty cool. And we have professors. Well, professor is pretty empty, and we are gonna add it here. Okay, so let's run this command, and now we have the professors as well. Okay, ID is auto allotted, and department ID is right here, which is a foreign, I would say a reference or foreign key. Now, so we already did this part. I want to show let's see, somebody says like I want you to show all the people in the all professors and their departments. Okay, so how are we gonna write the query? Pretty simple. Select all from professors, inner join departments. Now they are doing like D2. I mean, my data grip is doing. I don't like this. I don't like to be vague. I don't like to use variable name which is not very understandable. So I'm just gonna leave it departments. Okay, pretty simple. And this is the inner join. One second, let me run this again. This is the inner join. Let me check one thing. Okay, cool. So now we are here. You have all ID, the name of the professor, department ID, the ID of the department, and the name of the department. Pretty simple, nothing crazy. Now here is where the problem arises. A lot of times what we do is we provide filters as where clause, right? Where for all the results which is showing up in the join, we're trying to filter now, right? So we are gonna do where, and where is gonna work on whatever is the result of this. Okay, so post filtering. All right, and then we provide like where ID equal to this, or department ID is this. But a lot of time you might have seen people doing this as well, and this is the topic of contention or topic of attention in this particular video. Okay, so I'm gonna do on. Actually, on is already there, and right, departments.id. Okay, I'm not gonna leave it vague. Department.id is greater than 3. You know, people do that, right? So it's kind of an on condition, extended. I mean, filter condition on the join using on. Okay, so now we got this for like professor, and here's the geography. Pretty good. We use the filter condition in the join itself. So on filter in the join itself, and it worked, right? For inner join, it pretty much worked. Awesome. But let's see what happens for left join. Okay, so I'm gonna just pretty much add everything I did here. Departments on, and I'm just gonna pretty much copy paste here. Okay, all right, if I do this, this is all good. But now when I add this condition like extended on, or I add the filter condition in the join, let's see what happens. What do you think will happen? What do you think will happen if we do left join? Okay, before we go here, let's do actually what will happen is what will happen when we do a where. Awesome, this works, right? Because we did a left join. We want everything from the professor table, and then on a department, and then we added the filter condition. But what happens if we we use where, and we use an like filter on the on condition itself? in that case what happens is, when we run this, you see what happened? It's kind of weird. This is not the result we wanted, right? But here you can see we got all of these people from the professors table, and on the right side we got, for the cases where the department, or for the cases where this filter condition worked, we got full data across both the tables. I should say join of the table. But for the cases where there was no match, it put a null on the right table, which is department table. And this is very interesting. And the reason, I'll tell you about the reason, but you can see this can cause a lot of issues. Unintended result. Even though you will read this query as, oh, I'm doing a professor left join department, and then I'm putting a filter, but actually you are not, like, it's not really filtering the result. It's not giving you what you want, right? The reason is because using filter, first of all, what is left join? Left join is take everything from the left table and left join with the right table. Just make sure that, just make sure that everything on the left table is present. If something is not matching on the right table, as per the join condition, just put a null on the right side. So in short, the join condition, the filter condition is not going to be respected here. What really happens here is, when you do a filter condition on the join, the filter happens before the join happens. So the filter condition when apply on the department table, it will grab wherever ID is 3, then it will join with the right table. So it will give you all the data which shows up here. Right, like this guy and this guy. And then it will do the left join, the reasoning behind left join. It will do all of that logic, which means now match, respect the filter, but then get everything from the left and then left join with the right. In that case, if the filter condition is not matching, put a null on the right side. Got it? If I do this, there's no null condition because the filter condition, I should say the join condition has no filter, right? But if I do this, the join condition has a filter. Okay, why is it opening like this? 1 second. Okay, the join condition has a filter. So it will join, it will kind of inner join on all the matches, but for the cases where the join condition is not respected, it will put a null value on the right side. Okay, and this is very important, but you're gonna get everything from the left side. We can just copy this and try it on full join as well. Okay, full outer, full join, whatever you want to use. And let's see again. Boom. Not good, right? It matched all the cases where the filter condition matched, but then did what a full auto join should do, right? So it pulled everything from left, everything from the right, and join it together. Wherever left was not available, remember, on the join condition, and you have a condition here, right here. So if you remove this condition, then it will join really well. So you have like really matching, left right matches really well. But now you have added a join condition, so this totally changes the meaning. Now the department ID reference is not gonna be respected because your join condition is different. Okay, similar is the case. By now you'd already understand what I'm trying to say, but let's try with right join. I'm just gonna copy paste. There's no need for writing the whole query again and again. And same thing, it matches everything which matched as per the join condition, but then pulled everything from the right side, which is the department table. So if you want this result, then okay, you can use this. But if you wanted to really add a filter and you want to filter out cases where which is not respected as per your filter condition, then the best idea is to use where. So I would say make it a habit of using where in all cases, just to be really just to make sure everyone understands. Unless of course your use case is that you want to show up everything on the right side as null. Okay, like the way, like if that is the use case, then sure, go ahead, use on condition and use the filter. But for inner join, it doesn't really matter, it's the same thing. But for especially left join, always use where condition if you do want to filter out the value. I would recommend, like, if you have to do write this is not really a good query. Instead, if you have to do left join and then add a where, then just do an inner join. Don't do a left join. Okay. Similarly, if you want to do a filter and then do like a full outer, or you want to do a right join and add a filter, don't do a right join. Okay. And you want, by the way, when I'm saying that, I mean, if you want the filter to be respected and the results which are not respected by the filter should not be shown, then don't do full outer, don't do right, just don't do left, just do inner join. Okay, with no conditions, because it doesn't make sense to have condition if you're using those filters on the left, right, or full join to remove results. Now again, the use case where it does make sense is you have a table where there is reference and everything, there is join, but you want to add extra. Okay, you want to add some extra conditions, and then you want to have exact behavior where you do want your left side of for left join, for example, you do want the left side of the left table to all show up, but with the filter condition you provided, you want null on the right side. In that case, okay, go ahead, use or I should say use the filter on the join condition in left join, full auto join, or right join. Cross join, it doesn't make sense because cross join is pretty much just pulls everything together. So actually, if you do this on data grid, it will give you an error. Okay, so let me try this. It will right join instead of right join. I will do cross join, and it will give an error because in cross join it doesn't make sense to provide anything, because cross join pretty much means take everything from left and everything from right and do a Cartesian cross product. Okay, this is what it means. So it doesn't really make sense to talk about this in the cross join case. But anyway, I hope it made sense. Remember, if you want to filter result out and don't show it in the final form, then and you are using left join, anything other than inner join, then don't use the condition in a left join. It doesn't make sense. Use a where clause. If you do want to use where clause with filter conditions, then actually just do inner join. Okay, that's the right use case. But if you do want everything from the left side but only null on the right side, where as per the filter condition you have provided, then that is the right use case for using filters in join for anything other than inner joins. Make sense? Now the reason behind this is the filter is in PostgreSQL, the sequence of instruction is that the filter join condition is actually evaluated before the join result. Okay, so before PostgreSQL creates the left join result, the view, it will apply those filter, okay, on the left side, and then join will happen. So it will grab everything which follows that that condition, okay, and then it will try to join, and whatever is coming out of the table, it will try to join left join with the right table. So in short, you'll get everything from left table. In the case of left join, you'll get everything from the left table, and you will apply if you will mainly get filter result from the right table, and then the join will happen. The right use case would be, the right way to do it would be to use where clause, because where is run by PostgreSQL after the join table, the join view has been created. So if, for example, inner join happens or left join happens, and then filtering, so you get like left join, and then you get everything from left, everything on the right, and then the where clause is applied on top of it, okay, on that particular view. So then it filters out all the results which should not be there. So this order of execution is very important, and that is the reason why filter condition inside join versus use of where is so important to be considerate about. I hope it makes sense. All this code will be available on the newsletter. I'm just gonna add it just after finishing this live share. I hope it made sense. If it didn't make sense, no worries. Let me change. Okay, there we go. If it doesn't make sense, go subscribe to the newsletter. If you want to ask me a question, I would always answer, like priority wise, I would always answer question of the paid user of my newsletter, because that's the logical way of going about it. I'm running business. But if I have some extra time, I would be able to answer your question if you still get some confusion. But yeah, as per this video, be really careful about this. Understand the order of execution for where versus the join, like filter join. One happens before the filter table is created, and one happen after the join table is created. Okay. Be very careful about using filter condition on left, outer, and right join. Inner join, it doesn't make sense. Do what you want. Also, the use case should be important to think about. If you have to use the where clause on a left join, then just use an inner join. It doesn't make sense to use like it's the same thing. It's like it's gonna be converted into an inner join anyway. So use an inner